the need to store vast amounts of computer data has become a necessity, and all of this virtual stuff needs a place to be kept and organized. Solid-state drives now offer a new generation of memory chips. They're more compact, more durable, and faster than traditional hard drives. In a similar way to portable USB drives and camera memory cards, solid-state drives store information on several memory chips installed on a circuit board. Each chip contains complex circuitry made of electrical pathways 2,000 times narrower than a human hair. Production of the memory chips begins with a disk of wafer-thin silicon. Despite being a non-metallic element, silicon conducts electricity, but it's highly susceptible to contamination, and so the production area must be kept virtually sterile. An automated system moves the silicon through more than 800 operations, which take more than a month to complete. The chip's components are gradually built up using layer after layer of materials, some of which are conductive, such as copper, and some non-conductive, such as silicon dioxide. After applying each layer, the machine coats the embryonic chip with a light-sensitive fluid, before flashing it with UV light through a glass stencil shaped to the pattern of the electrical circuitry. Where the fluid is exposed to the UV light, the chemicals break down and dissolve. But where the fluid is shielded by the stencil, the materials remain intact, effectively printing the pattern of the circuitry onto the wafer. Chemical baths then wash away the exposed fluid and dissolved material. Each 30 centimeter wide silicon wafer yields hundreds of microchips, which now have to be sliced apart. A robotic cutting machine first covers the wafer with an adhesive film to hold the chips as they're cut free. The next machine inserts each clipping into a protective plastic housing. Meanwhile, 6 circuit boards at a time enter a machine which applies a thin layer of tin alloy solder paste onto areas where the memory chips and other components will be assembled. As the circuit boards exit the machine, a robotic arm picks up the components required for each drive from feeder spools and deposits them at their correct locations on the circuit board. This model has 8 microchips, each able to store 64 gigabytes of data, which will give the drive a total capacity of 512 gigs. The circuit boards now enter a tunnel-shaped oven which melts the solder paste, fusing the components to the board. The brain of the solid-state drive is now complete and ready for the first phase of quality control testing. First, an optical scan is performed to check that every component on the board has been correctly placed. The next machine X-rays the board to confirm that each component is securely soldered into position. The drive's performance will be tested in a later phase of quality control. At this point, the 6 circuit boards are still attached to each other, but an automated router now cuts them apart before each board is inserted into a protective plastic housing. A slot in the housing reveals the board's connector, which will link the drive to the computer. Solid-state drives come in different sizes. Some, like this one, are large enough to replace a traditional hard disk drive, while smaller models may be designed to fit where traditional drives can't, such as in ultra-thin laptops. Every drive is labelled with its technical specs, its model and serial numbers, and a barcode so that its production can be tracked. The drive's connector is then plugged into a testing computer which checks that everything electronic is functioning correctly before installing the drive's operating system. At the next station, the drive undergoes up to 60 hours of extensive performance testing to ensure that it stores and retrieves data correctly and at its target speed. The packaging includes a foil shield to prevent static electricity from damaging the drive, which means the drive is ready for shipping to destinations around the world. And with an estimated 1.5 billion personal computers in the world, that sounds like a pretty good gig to me.